In this lecture, what we're going to do is we are going to continue our simple correlation analysis using Microsoft Excel. Now, the problem with using Microsoft Excel, particularly the data analysis module or the extension, is that it does not calculate whether these correlation coefficients are statistically significant or not. So what I've done here is I've copied and pasted the two fundamental equations that we need in order to calculate the statistical significance and testing our null hypothesis that rho is equal to 0 for each of these correlations. So the first step is to calculate the standard error related to these correlation coefficients, and the standard error is going to be a function of the correlation coefficient and the sample size. So the first thing I'm going to do is I'm going to copy these headings. I'm going to place this over, I'm going to put this right here. I'm going to move over 2 columns, and I'm going to copy these headings. I'm going to copy and put these right here over this one column. And I'm just going to give this a label SR as to what I'll be calculating over here. Now, the standard error has to be calculated for each of these coefficients. So I'm just going to type the equation in and make reference to the correlation coefficient cell. So although this is pointless to do it for the first cell, I'm going to go ahead and do that anyways, just to type the equation in. So I'm going to hit equal, and Excel's waiting for me to type in either a command or an equation, and in this case I need to type in an equation. So because I'm taking the square root of the of what will eventually be the quotient inside this radical symbol, I'm just going to use the Excel command of SQRT. I'm going to open parenthesis, and I'm going to open parenthesis again to isolate the numerator in this fraction, and that is going to be 1 subtract the R value, and I'm just going to click the cell for that R value, and I'm going to shift 6, so hat means I'm going to raise that value to the power of 2. I'm going to shift 0 to close the parenthesis, then I'm going to hit the / for dividing by another quantity, which I shift 9, open parenthesis, and I type in the sample size here, and the sample size, if you recall, is 100. I subtract 2, close parenthesis, but I have to close it again, and I hit enter. And of course we get a standard error of 0 because there's no deviation between score and score. But what that allows me to do is that allows me to grab the bottom right hand corner, pull it all the way down, and now I've calculated the standard error for each of the correlation coefficients, and I grab the bottom of the highlighted region again, and I pull all the way over. Now you can see that we have the same value up at the top part of the of our matrix because these are empty cells, so we can just delete these right here. So I'm just going to highlight those, highlight those, and delete and delete. And what we've done now is we've calculated the standard error associated with each of these correlation coefficients. So now we're ready to go ahead and calculate our t-value. So I'm just going to put in the t-value right here, and I hit enter. Now I'm going to copy these headings once again. So I'm going to copy, I'm going to move over 1 column, and I'm going to paste those, and I'm going to copy these because I need to create another matrix for the t-values. So for however many correlation values we have to have the associated number of t-values. So what I'm going to do here is I'm just going to go to this top one. This will be a meaningless value that we have here, but that's okay. But I'm going to go ahead and do that. So I'm going to hit equal. Now I want to take the actual R value, which is what we have here in our first matrix. I'm going to subtract it from rho, and in our null hypothesis we're going to set rho to 0. So this equation just simply becomes the R value divided by the associated standard error. So I'm going to click this value right here for this R, and I'm going to divide it by the associated standard error value here, and I hit enter. Now of course we don't get a number, because if we divide any value by 0, we're going to get an undefined value, so Excel cannot calculate that. But what I can do is I can click this cell and pull the equation. I hit the wrong button there, so I pull the equation down, and we have the associated t value for each of these r values. And I'm going to pull this over this way, and we see a lot of values that cannot be calculated, so we could just delete these up here. We can delete the diagonals as well, and we delete that. Now we have the calculated t values associated with each of the correlation values, so that we can evaluate statistical significance. Before we calculate the p-value associated with each of these t's, we have to go back up here to the ones with a negative value, and we have to make a slight modification, in that we have to convert that to an absolute value. So I'm going to type in ABS for absolute. I'm going to shift 9 for open parenthesis, and I want to take the absolute value of the fraction, and I hit enter. And I'm going to do the same right here. So I'm going to take this cell, and I'm going to type in ABS, open parenthesis, scroll over to the end, close parenthesis, and now we have all of our t values in positive, so that we can go ahead and calculate the associated p-value. So that's going to end this part. In the next video, we're going to step through and calculate the actual p-values for each of these that will tell us whether the statistical or whether the correlation coefficient is statistically significant or not, thereby informing our decision to accept or reject the null hypothesis.